Good afternoon to all. Now start this session.
Good afternoon, sir.
Good afternoon. It gives me immense pleasure to welcome you all to second day of our 5 days faculty development program on uh, recent advancement in civil engineering, organized by Department of Civil Engineering, Institute of Management and Technology, Bareilly, in association with the Institution of Engineers India, Bareilly Local Center, Bareilly. After a highly in, insightful study, we continue this academic journey with renewed enthusiasm. Today, we are privileged to host two distinguished experts from the field of civil engineering. We will joined by Dr. Ketan Kumar Nandi sir from SR University, Warangal, known for his significant contribution to structural engineering and concrete technology. Following him, uh, we are honored to welcome Dr. Nidhi M., Assistant Professor at NIT Pondicherry, whose research and academic work in structural health monitoring, forensic engineering, and machine learning applications in civil engineering are highly commendable. We are confident that today's session will provide deep insight, stimulate intellectual discussion, and enhance our understanding of cutting-edge development in our field. Thank you once again for your presence, and I now look forward to engaging and fruitful day ahead. Now it is my honor to invite our first esteemed speaker of the day, Dr. Ketan Kumar Nandi from SR University, Warangal. Dr. Ketan sir is currently serving as assistant professor in the Department of Civil Engineering at SR University, Warangal. He holds a PhD in civil engineering from IIT Guwahati and has completed a prestigious PDF with his research primarily focus on hydrodynamic and river ecology. Dr. Nandi's sir academic journey include both teaching and research role at reputed institutions such as IIT Bhubaneswar and Sivnadar University. His research work lies at the intersection of experimental and numerical modeling, aiming to provide sustainable solutions for river corridor management. His areas of expertise include flood control, erosion protection, and ecological resilience, and he actively contributes to understanding of complex water system. With numerous publications in reputed international journals, Dr. Nandi's work has had meaningful impactful on the field of water resource engineering. He has also actively involved in the guiding research scholar and participating in collaborative academic initiatives. A strong advocate for integrating science with the real-world applications, his work continues to address some of the most critical challenges in river and environmental management. Welcome, sir. Please, sir.
Okay. Hello, sir. I
Yes,
can
sir.
start. Okay. First of all, thank you for introducing me. There are some mistakes are there. It's okay. Uh, my research area is river engineering and river health management. So I know we are related to structural engineering. So and one more thing, I'm not nowhere associated with Sipnadar University. I'm from SR University.
Oh,
It's
sorry.
okay. It's okay. No, so I can start my presentation. Uh, Now it is showing the.
Still no, sir. Ah, now is okay.
Yes, sir. Visible.
Now I can start.
Yeah.
Uh, so, first of all, good afternoon, everyone. I am Dr. Ketan Kumar Nandi. My PhD is from IIT Guwahati. My main research area is about river corridor management using satellite imagery as well as computational numerical modeling and experimental modeling. So today I'll discuss the application of cloud computing in river corridor management, how we can use easily the satellite images available nowadays, freely available satellite images. We can use it for river corridor management. There are vast of application for the use of these satellite images, but today I will focus on the use of these satellite images in river corridor management. So uh, we'll okay. So today we'll discuss, these are the discussion points, basics of remote sensing, next application of remote sensing, then satellite images processing using RGS. Next, we'll discuss about what is cloud computing, how it is being utilized in the satellite image processing, and what are the advantages over using the traditional RGS method. And finally, we'll see some satellite image processing in Bullard engine. We'll have some hands-on for 10 to 15 minutes. So, first of all, what is remote sensing? So, everyone might have heard about this word about the Earth surface. So how we can get the information? How we can identify different features in it? Just like there are some trees are there are some buildings, there are some agricultural fields, there are some water bodies, there are some different kinds of features is present in the Earth surface. So how we can identify those features using the satellite images? That is nothing but remote sensing, because here we can uh, collect the photos or collect the information using some satellite present in the atmosphere or over that. We'll discuss. Then you can see here the good picture that is describing the process associated in the remote sensing. These are, you can see here, 1, 2, 3, 4, 5, 6. Here, one is the source of energy. Anything, if you click a photo, let's say you are clicking a photo from your phone. So how, what are the processes associated when you clicking the photo? It requires some energy. Here, the energy is light when you are clicking the photos. If there is no light, so the mobile has some inbuilt process. The flashlight is there. So using this flashlight, it can take the photo. Similarly, in remote sensing process also, it's one satellite getting some photo from the Earth surface, it requires some energy. This energy is nothing but the sunlight here. And then two is atmosphere. Sunlight is sun is radiating some energy in form of sunlight. So it will first interact with your atmosphere. Then it will some of the energy will be reflected back by the atmosphere. Some of the energy will be absorbed by the atmosphere. Then some of the energy uh, will penetrate and comes to the Earth surface. Then comes to three. It will it will be absorbed and reflected back by different features present in the Earth surface. Just like I have discussed, there are different forest area is there, agricultural field is there, urbanization is there, water bodies are there. It will the energy will be absorbed by this feature, and some of the energy will be reflected back to the satellite. So using the reflection, using this back propagation, or the reflecting back energy will be stored in the satellite, and this then we'll do some means there will be some process to identify what type of features have what type of features are there. Like forest will show some different feature, and this urban area will show some different feature. Similarly, water body has some different feature. We'll process it to our computer. So again, four is collecting this radiating energy, collecting this reflected back energy by the satellite. This is four. Next, five. 5 is your antenna receiver, means whatever data is collecting the satellite, then it will emitted to the emitted to the antenna receiver. Then you can process this data using your computational facility. This all are the process of remote sensor. So I think you are this will be clear. What actually what is the role of different energy and how the different features are observing the energy, and some of the energy is reflected back by the features and it will collected through the satellite. Then uh, uh, satellite sends the data which will be received by the antenna and receiver. Then you can use this data to your as per your requirement for and some data processing you require to final to get the final data whatever you require as per your requirement. So you can go to the next slide. Now magnetic spectrum. So we can see here. So different features of different electromagnetic ranges. Just like you can see here, the you can see this is the wavelength, and there is a relation between wavelength and this frequency. Okay, different wavelengths have different frequency range. So as for the this wavelength and frequency range, we can identify different features. So what is that actually? You can see here radio wave have 10 to the power 3 range. Then microwave is 10 to the power minus 2. Then infrared is 10 to the power minus 5. Then visible range is 0.5 into 10 to the power minus 6. Then ultraviolet has the range of 10 to the power minus 8 meters wavelength. Then X-ray has 10 to the power minus 10. These are gamma rays is also there. We can see only the visible range. You can see here. Our naked eye, we can see only this visible range. That is, you might have heard about Vibgeo. These colors we can see by our naked eye. But here infrared is there and ultraviolet UV rays is also there. So you can see here it is a good figure. This is the frequency distribution of radio wave. Microwave has again larger frequency distribution. Infrared has again larger. Then it is increasing, and gamma rays has more frequency. Gamma rays has more frequency distribution. Okay, now you can see here different wavelengths have different frequency distribution. The frequency is higher in case of gamma ray, and it is lower in case of radio. Uh, so this is all about the electromagnetic spectrum, which is used to identify different features, and how this frequency helps us to identify different ranges of this. As I have discussed, the radio wave has the frequency of 10 to the power less than this is greater than 10 to the power 9, and wavelength is greater than 0.3 meter, and energy is less than 7 into 10. Yes, hello. Yes, can I continue?
Yeah, no issue.
Okay.
Please.
Okay. So you can see here microwave has also some ranges. These are listed here in the table. Infrared has far infrared, long wave infrared, then mid wave infrared, then short wave infrared, near infrared, and visible region has red, orange, yellow, green, blue, violet. These are this can be seen in our naked eyes. Then ultraviolet is there. Then X-ray is there. Then gamma ray is also there. So these are all about electromagnetic spectrum. So now, if we have the data, if we have the images, then what type of what type of process we have to do to identify some features, identify the required parameter, what we want to extract from this particular image. So once satellite gives us the image, then what happens? We have different, I have discussed different kinds of, these are their colors is there, red, blue, green, all the frequency, all the electromagnetic spectrum I have discussed here. These information are stored in a particular image in form of pixels. So from that pixels, we want to extract some particular feature. So for that, we have to process this data. So you can see here, this is a comparison between TCC and FCC. TCC is nothing but true color composite. Whatever color is there in a pixel, it is stored in that particular pixel. But false color composite is nothing but we are assigning some other color to a particular color. Means if we are trying to get some features for vegetation, let's say vegetation, or we are trying to get some features for, let's say, water bodies. So we have to assign different color to different pixels. So that this can be uh, comes to FCP, false color composite image. So false color images are a representation of a multispectral image producing using bands other than primary color. Whatever primary color is there, RGB, these are the primary colors, and we are assigning different colors to this particular primary color. So it will give us the FCC, false color composite, to identify a particular feature like vegetation. Here, this figure, you can see the red one is all about the vegetation part. And this is the water body. You can see here, water body and bare sand parts and all. So it allows us to visualize wavelengths that human eyes cannot see. Just I have discussed this red, green, blue, we can see, human eyes can see, but the near infrared part that cannot be seen by a naked eye. Human eye cannot see this. So to identify this, we have to make a false color composite. So using the bands like near infrared can increase the spectral separation and is useful in proper interpretation of the data. I'll show you one. You can see here. Uh, See, if I I will assign different color. See, here red is there. Original color is red. So we'll assigning a different color. Let's say band two. Then green is there. We'll assigning some different color. Then blue is there. We are assigning some different color. Let's say. So what we get? See, this is one type of false color composite. This also gives some information about the. So similarly, we can play with different combinations. So we can go to red, then two, then one. Let's see what happens. See, now it is also one false color composite. It gives us extracts the uh, data vegetation. These are the vegetation zone in network. This is the first color composite. So if we cannot, our naked eyes, human eyes cannot identify particular things, then we have to make the false color composite so that we can extract a particular information from the image. Now, okay, comes to this presentation. Then what is remote sensing platform? Okay, these are some remote sensing platform. One is ground based, another one is airborne, and again, there is also some satellite which acts in the space one. The ground based means you can use low flying satellites. Low flying satellites means if you are using the drones, you are using some means photographs you are taking from low height from the ground, then it comes under the ground based. Nowadays, you can see the ground based the drone activities are more because we want to identify we want to identify the features using the high resolution images. For that, the drone survey is required. So drone gives us the high resolution images. Similarly, there are aerial television means helicopter. The cameras are fitted with the helicopter, and the helicopter is flying a particular zone to get the images, and we can identify different features from that also. There are also aerial photography is there. That is, you can see here range is also written here. 1.2 to 3.5 kilometers. Here drone is having the range of 1.6, sorry, 150 meters from the ground surface, and the aerial television is from 0.3 kilometers from the ground surface. And there are airborne SAR. SAR is nothing but synthetic aperture radars. These are the microwave satellite arrangements. These are something else we'll discuss later on. So these are the ranging 10 to 12 kilometer from the ground surface. So, and the space-borne satellites are the satellites we are launching. You might have heard about the ISRO launching some satellites. These are the space-borne satellites. Okay. Then there are also space shuttles are there. Space shuttles nowadays they are not using these space shuttles. Now nowadays the satellites are nowadays more usable now. But space shuttles are nowadays not using. They are not using. It is around 185 to 575 kilometers, and these satellites are 700 to 900 kilometer range from the ground surface. And you can see here the ground coverage, the ground coverage area versus the operating altitude. The ground based is in between this range, 1 kilometer to 1 kilometer square range. Then there is small small UAS, and there are unmanned fixed wings also there. Then there are airships also there. Then stratoscopic platform are also there. Stratospheric platform are also there. Then remote sensing satellite. This is our concern. We are looking into this only. This remote sensing satellite. Just like Sentinel is there, Planet is there. We'll discuss about it. These are the satellites which provides us the data to carry out our concern parts. Means if we are concerning about the agricultural how the agricultural activity is going, what type of changes is required for a sustainable agriculture part. That for that we have to analyze different types of satellite images. This will be provided by this remote sensing satellites. Then geostationary satellites also there. Geostationary satellites are the then land use, land cover monitoring, environmental management, flood risk assessment and monitoring, planning and engineering, weather and climate monitoring, geology and mineral resources, oceans and coastal monitoring. Also in hydrology. So these are there are other uses also, but as a water resource point of view, these are the major areas where we can use the satellite remote sensing products efficiently. Nowadays, you can see the land use land cover mapping, the LULC mapping. What are the changes due to a particular event? If the flood is there, then how it affects our agricultural land, how it affects the river corridor. So it can be done. The change identification can be done using this satellite image analysis. Environmental management also, flood risk assessment. How much inundation is happening during the floods? How much area are affected due to a particular flood event? How to monitor this? This can be done using the satellite products. Also, weather and climate monitoring, the rainfall events, the means we can identify different rainfall events and what is the intensity of this rainfall event, and where the rainfall is more at a particular area, what are the effects due to a particular rainfall event. That can be also monitored by using the satellite products. Geology and mineral resources, obviously we can do the mineral resources identification. What are the resources present uh, inside our ground, that can be done by remote sensing application. Also, ocean and coastal monitoring, and finally hydrology. Hydrology means all the all the hydrological modeling. If some rainfall happens, how the runoff is generated for a particular catchment, what are the parameters affected by this particular rainfall event, how the flood inundation is going on. This comes under hydrology. This can be also done in remote sensing, done using the remote sensing products. So now for I'll concentrate about the river corridor management. So for river corridor management, what is actually a river corridor? River corridor doesn't mean that what is there inside the river. No, a river the water is flowing through the river. Due to the flow with tide, it will deposit some material. There is some deposition. There is some erosion. The sediment coming with a particular flow, it will deposit it somewhere else in the length of the river. So this depositional unit, we have to identify this depositional unit, where the deposition happens, why the deposition happens, and this is inside the river, in stream unit. Also, what are the floodplain? Floodplain features are there, like agricultural. You might have seen the agricultural field near the means near the river, on the floodplain of the river. There are some forest near the river. Also, some island inside the river. Just like Brahmaputra, if you visit the Brahmaputra river, there are beautiful islands inside the river also. You might have heard about the Majuli Island. It is a beautiful island. This is a river island. Inside the river, one big bar is there, and there vegetation arrangements is there. All the things are there. This is the island. So to identify this island, how to identify this island using the satellite images. So what are the impact of different flood events on this island? How the bank erosion happens? If the bank line in a particular season, if you are considering a bank line in a particular season, then one flood happens, then one flooding event happens, and due to this flooding event, how the bank line changes, whether it goes inside the river or whether it goes outside the river. The oscillation of the width of the river, that also can be identified using the satellite images. Not only that, how the vegetation interaction is going on, how vegetation can stabilize different river units, different in-stream units like bars, like banks, uh, and different agricultural activity also affect the stabilization of the bank. That can be done. This all comes under the river corridor. So I think this is clear. What is river corridor management? To manage all these river corridor units, to manage this in a effective way, in a efficient way, it is a you can say this will help the river in a healthy state. Means the river will flow in a healthy state. If we uh, forcibly intervening towards the river, so what happens? Uh, if we are forcibly intervening towards the river, so it will affect the downstream part, maybe affect the upstream part, whoever is depending on that river. So the social, social as well as economical impact is there due to the this type intervention. So the anthropogenic stresses. What are the anthropogenic stresses which affect this river corridor? This has to also take care when doing this management of river corridor. These all are related to river corridor management. So now, how to identify different features present in the river? So for that, we have to identify what are the water way present in the river, and what are the depositional units present in the river and in the river corridor. Not only inside the river, also river corridor side of the river, floodplain of the river. So for that, this is a good index, that is modified normalized difference water index, MNDWI. Uh, this is nothing but it is actually uses the green and shortwave infrared swave bands for the enhancement of open water features. It is also demonstrates built-up area features that are often correlated with open water in other indexes. Okay, actually what happened? MNDWI just use the green and sware band, green minus sware by green plus sware. That means you can see here, green. This is the green part. The wavelength is between this to this. This is the green part. Okay. Blue, green, red. Then near infrared. Then this is mid infrared. Okay, region. These are the regions. So you can see here, if we are calculating the MNDWI, green minus red, what is the here you can see the water has the more power, means more reflectance value. The reflectance is the water feature has more reflectance value within the green region. So if we subtract the shear part, shear means this this shear part will give us the less water value. So from let's say the green has the highest water value, then Suya has the SWIR has the less water value. So if we are subtracting, then the water feature can be enhanced. So it is enhancing a particular feature. So from that we can identify the water feature. So whichever has higher value of MNDWI, it can be considered as water, and others are land. So we have a threshold value here. 0 to means less than 0 is identified as land feature, and greater than 0, whatever positive value we get for MNDWI, it will be identified as water feature. This is the basic rule. Uh, there are also some deviations in the identification criteria, but the basic is less than 0, it is identified as a land feature. Greater than 0, it is identified as a means water feature. Now comes to normalized difference vegetation index. Okay. Now I have discussed that there are some uh, depositional unit inside the river which has maybe the vegetation on it or may not be vegetation is there. So means if vegetation is there on the bars, so how to identify that bars, how to identify this vegetation? So for that, we can use this NDVI index. That is nothing but the normalized difference vegetation index. Here, NDVI is calculated as NIR minus R divided by NIR plus R. NIR you can see here near infrared, but this you can see vegetation has the highest value in the NIR region. Vegetation has the highest reflectance value in the NIR region. So if we are calculating and red has the lowest, NIR has the highest. So for that we can use this index NIR minus red by NIR plus red will give us the uh, enhanced form of vegetation. Means the feature will be identified if a NIR is higher, because vegetation has higher reflectance in NIR zone. So similarly, just like MNDWI, NDVI also used for this uh, feature identification for vegetation. So now, what is cloud computing? What is cloud computing? Cloud computing is a model for delivering computing service, including servers, storage, database, networking, software, analytics, and intelligence over the internet. So let's say we are using higher resolution data to process some satellite images. Just like one images can be 10 to 20 GB of memory. So if we are using this in a normal computer, we cannot process this data. Uh, and we are not processing a single particular image. We may be processing n number of images. Can it be done in a simple computing facility? No, it required higher computing facility. So getting a higher computing facility means higher investment is required. For that, it is not possible. It is not possible to all to process this higher frequency, higher resolution data in a normal computer. So that's why cloud computing helps us to uh, process this data, and the platform will be used, that is Google Earth Engine platform, GEE platform. We'll discuss about that. Then, by cloud computing, you can see these are different rivers. We have processed this data. Like this is Kameng River. The second one is Mahanadi River. third one is Brahmaputra River. It is done in, you cannot believe this process are done in 2 GB RAM and Intel Atom processor with a 10-year-old computer system. So processing this is not difficult, even if in a basic computer, because you are using the cloud computing, cloud platform. All you require is the internet connection, nothing else. So all the process, all the algorithm, all the means all the calculation, all will be done in the over the cloud only. So you need not to worry. You just develop the algorithm, you just write the code, it will give you the desired results. So uh, now we can, this is the basic, you can see this is the basic user interface of a Google Earth engine. We'll have some, we'll run some code. Okay, now you can see here, this is basic Google App Engine code editor. First of all, the basic thing you have to do, you have to log in. I mean, you have to create an account in Google Ads Engine. It will be done by your Gmail account only. You just there are some basic questions you need to fill it up, and you will have this Google Ads Engine account. Then comes to Google Ads Engine code editor. Then you can see the user interface is like that only. Here, script is there. Well, then docs is there. Docs is, these are the predefined functions to which will use to call different types of means these are the predefined functions you can see here. Basic code required and not required higher code knowledge. These are already well defined feature functions are there. Then there is asset. Any set file you need, uh, any features you need for a particular set file, you can load it here and you can use it in the script. So this script means you will write the code here. For I just write down it in for MNDWI calculation, whatever I discussed earlier. MNDWI classification, identification of different water bodies and different land bodies inside a river. So for that, you can see here, I have this. This is the region of interest. You can see here the white color one. This is the region of interest where I need to find out what are the waterways and what are the depositional units. Here, you can see there are variables for years. I can download any year. Uh, for now, I just show you the 2023 image. For that, there are some basic. Here, I have used different functions as I have discussed here. You can find out different functions as per your requirement. Here, my aim is to, I will collect the image, the Landsat, collect the image from Landsat 8. So how to get this one? This this one. This is, you can find it. I have already opened. You can search here. Browse. You can search here. Browse data catalog. Then it will redirect to this page. You have different you have different features here, like for climate and when the weather, surface temperature is there, climate is there, atmospheric features also there, weather is there, different imagery like Landsat image is there, Sentinel image is there, MODIS is there, high resolution imagery also there for higher data identification. And geophysical, for geophysical exploration also you can use this terrain modeling, land cover, land use identification, agricultural activities, other geophysical data also available in this data catalog. So our aim is to now I can use this. We are using mostly this Landsat and Sentinel data products. Explore. Let's say we are exploring what are the data available for Landsat. So you can see here there are different from Landsat 1 to Landsat 9. There are the Landsat 1 to 5 is available from 72 to 99. Landsat 4 product is available from 82 to 93. Similarly, 584 to 12, and after that, Landsat 7 is most popular, 99 to 21. 2013 to present, Landsat 8 data is also there. Now, uh, this Landsat 9 is the most recent one. From 2021, it is available for general use. So these are the Landsat collection. So let's say I am using here uh, Landsat 8 product. So for Landsat 8 products, we can, let's say I want some surface reflectance image, tier 2 image. So you can see here. Here this code is already, the script is mentioned. Google Earth Engine snippet. This is the script required for this one. What is your variable data set? The variable data set is nothing but image collection for Landsat 8, LC08, C02, T2 tier 2 for L2. So we can use this image collection to get my data. So I have used here in Landsat 8, green is for B3, square is for B6, then simple arithmetic calculation, green minus square by green plus square. Then we'll store this data in the MNDW image. Then this is to visualize the image with different image means image different color combination. So we can change this also, no issue, as per your visualization requirement. So and also we can download it. So if I run this code, it will give me this kind of result. You can see here for my particular region of interest, it is showing these are the water water waterways, and these are the different land features. In-stream depositional unit. The white are the in-stream depositional unit, and this dark blue color, I mean green color, is showing the waterway. You can change this color combination also using the palette. So we can see for NDVI also. So for NDVI also, I have used this normal NDVI means for, let's say, okay, uh, I can use only this part for a particular year. Some error is there. Landsat 8. Why this error? Because we have already seen Landsat 8 is available from uh, 2013 to present. So I have used here 1989. It is not available. So if we use 2021, then let's see is there or not. No. Okay, I think some okay. I think the base file is missing. Uh, Maybe there is some removed. Okay, the asset is removed. So the base file is uh, let's try this image. I think some asset is missing here. So just like MNDWI, you can use your NDWI, NDVI, NDVI. Okay, there is something problem is in the code for NDVI. I'll have the code for NDVI. I'll look into it. Maybe there is the base file is missing about the asset, so that's why it is showing some error. So like that, MNDWI, you can use the NDVI just like MNDWI is clean minus your by clean plus your. That is NIR minus rate by NIR plus rate. You can uh, replace here and get the NDVI image. So, so that is all from my side. Thank you. Hello.
Yes, sir.
Yes, yes. Now you can discuss if you have anything doubt regarding this.
Yes. Anything is, please ask directly or chat box.
You
Please.
can, sir, you can do one thing. You can also provide my mail to them. I can share the
Sure, sure.
codes if anyone needed this code or anyone particularly working in this area. I can share them.
Yes, sir. Also provide a recorded session on your WhatsApp or YouTube.
Okay, okay,
Have any query, please ask directly or through this chat box.
okay.
I think no, sir.
Okay, okay. No issue. If you have any query, please send me through my mail. I'll
Sure,
answer
sir.
those.
Sure, sir. Thank you, sir,
Okay,
Dr.
okay.
Ketan Kumar, sir, for
Thank you.
your
Thank you.
enriching session on remote sensing. Your detailed insights, the remote sensing process, electromagnetic spectrum, infrared sensing, TCC and FCC imaginary, and spaceborne platform were highly informative. The discussion on multispectral indies and their applications in civil engineering added added great value. We sincerely appreciate your valuable contribution to our FDP and look uh, forward to more such enlightening sessions in future, sir. Thank you,
Thank
sir.
you. Thank you.
Thank you, sir.
एक ही क्लास में तीन चार
हाँ तीन लोग आपको तो वैसे भी बैठने हो जाएंगे
Second session start within 10 minutes. So please stay here.
Yeah, I think I'm in. Good afternoon, everyone. Can you hear me?
Yes, madam. Yes, ma'am.
Once again, thank you to join this second session of second day. Now I introduce to Dr. Nidhi ma'am. Dr. Nidhi M is an accomplished academician and researcher currently serving as an assistant professor in the Department of Civil Engineering at National Institute of Technology, Pondicherry, Caracal. She completed her PhD in civil engineering from NIT Calicut with specialization in structural engineering. Dr. Nidhi has previously worked Jyoti Engineering College and Federal Institute of Science and Technology, gaining valuable teaching and research experience. Her research interests include beam column joints, structural health monitoring, forensic engineering, fiber reinforced and geopolymer concrete, and application of machine learning techniques in predicting concrete properties. She had guided numerous student projects and published several research papers in reputed national and international journals and conferences. She is honored with a prestigious ICI Ultratech Award for Best Thesis in Kerala and received Best Paper Award at NCRC 2014 conference. Dr. Nidhi is known for her dedication and academic excellence, innovation, research, and commitment to developing sustainable engineering practice, making her respected contributor to the field of structural engineering. Thank you, ma'am. Please welcome, ma'am.
Thank you. Thank you so much for the warm introduction and inviting me for this faculty development program. Thank you once again.
Thank you, ma'am.
So, shall we start with the presentation?
Yes, sir. Yes, sir.
So, are you able to see the screen?
Yes, ma'am.
So, right away, we'll start the presentation. So, I hope all of you are from civil engineering background. And
Yes.
yeah, how many are from structure background?
Not-
Okay, are we talking to only faculty members
Yes,
or
ma'am.
or any students are there?
No,
Can
only
we take
only staff.
only faculty members?
Yes.
Okay. So let us start the presentation. So I am focusing on the topic structural health monitoring of slender masonry heritage structures. So right away we'll start. So this is the outline of my presentation. So first we'll discuss about what is structural health monitoring, what are the steps involved in structural health monitoring, and what is monitored. So what we are going to do in a structural health monitoring, how and why we are doing this, and an introduction about slender masonry structures. So what are slender masonry structures that we will discuss. Also, we will discuss a case study, so wherein we have taken some data in real structures, and then with that we have done some structural health monitoring. So after that, we'll do the conclusion. So this is the outline of my presentation. So you will be all will be knowing what is structural health monitoring. So I would like to show with this figure. So is the screen and all is visible to you? Are you able to follow?
Yes, working, ma'am.
Yeah, okay, fine. So, so when you get sick, you go to the doctor, right? So similar way, so the doctor will investigate the patient. Okay. I think someone. Okay. So the doctor will do some diagnosis and then suggest you some test, for example, X-ray. A health monitoring engineer will inspect the structure. Similar as any damage occurred, or if any damage has occurred in previously, or any damage is going to occur, or continuous monitoring of the structure also can be done by a structural health monitoring engineer. So it is a process of implementing a damage detection and characterization strategy for engineering structures. So, various damages, as we discussed, can be due to mismanagement in the construction. So, during the construction phase itself, if there is any mismanagement, there is no proper supervision, there can be damages. Also, similarly, if there is a lack of quality control, so if the quality control engineer is not present at the site or something happens, so if whether the proper mix is not done, so similarly lack of quality control can cause damages in structure. If there are variation in temperature, for example, hot weather concreting and all, so then also there can be initial cracks which can occur. And then when there is repeated loading or cyclic loading, for example, in the case of bridges, so all these things can cause damages. Apart from that, damages can be due to the geometric properties of the structure. So, for example, the geometry and the boundary conditions, that is a support condition, whether it is hinged, pinned. So, if due to if there are no proper maintenance, so normally for bridges and all, we'll put if there is a hinge or roller there, and then without proper maintenance, if there is no proper oiling or something like that, it cannot be like a proper roller support. So due to that, damages can occur. And also the overall characteristics of the structure, if there is any damage, we can so these are listed as damages. And why we are going for structural health monitoring? So structural health monitoring is to ensure the safety, because continuously we are using the structure. So if there is any damage occurring, so continuously we have to do it. And then replace. So normally what we do is that there will be some maintenance schedule. And then for that schedule, so only maybe after 6 months, we'll go for an inspection. So based on the condition based. Instead of routine maintenance, we can adopt like condition based. So for example, if what is the present condition? So after detecting the present condition, any changes, any damages is there, then based on that damage, we can go ahead with the repair strategy. And if there is continuous monitoring, we can increase the structure's life, and also we can detect the damages in the early stages to enable some responses. And due to this process, the total cost reduction can be achieved. So then, so for this, first we need to note down the system components. So what are we have to identify the system components. For example, where are we locating the sensors? For example, this is a tall structure. So for a tall structures, we can identify, so it is acting as a cantilever, vertical cantilever we can consider. So here we can identify different locations to put the sensors. So that sensors will give us the idea what is the condition of that structure, so that we can continuously monitor those structures. Similarly, for a bridge like this, a suspension bridge. So for this also we can identify various locations wherein we can inbuilt the sensors, and then we can monitor what are the how the progress is going, or if there is any damage occurring in the structure. Now, so various if you see, this is a structure or this is a bridge. So we have to identify where all we are putting the sensors, and once we put the sensors, there would be a data acquisition system wherein we will collect these data from these sensors. Then this is at the site, and then from this we can have different communication systems. That is, for example, with use of internet, we can process those data, what is occurring in this, and then we can monitor in our office itself. Then automatically processing the data by the computer, then we can store those data in CD, hard disk, whatever you want, and then you can diagnose the data. So we can retrieve the data and do the suggestions, or with the data we can find out what are the damages and what rectification can be made for the structure. So this is the overall process for this damage detection. Now, what are we going to monitor? What, how, and why? So for that question, let us consider the load. So the external load acting on the structure. So that can be monitored. What are the deformation occurring? What are the changes in the strain? So changes in strain we can monitor. So for these things, we need different type of sensors. So depending upon our thing, what we are going to measure, we can, depending upon our intention, we can put this sensors. So temperature, we can also measure acceleration, the speed, wind speed, pressure, then if acoustic emission. Also, we can monitor using the video monitoring. So continuous images will take, maybe from CC camera or some high resolution cameras we can build, we can install, and then from that we can monitor. We can also monitor the corrosion rate. So how much corrosion, the rate of corrosion which has occurred, or is the extent of corrosion which has occurred, what are the different cracking, any cracks are there, then what is the strength. We can also identify the tension, and also where these changes are occur, or where the location of distress also can be monitored. Now, so the first step in this monitoring process is the visual inspection. So wherever if there is some damage, first thing is that we need to go to the site, and then we need to observe the things. So for that, so we can consider a column. Okay, so for this column, we can see it is severely damaged. And then this person, he is gone to take some videos for detection. And then nowadays we can use drones for this purpose, for this visual inspection. So if there is a bridge like this, some areas may be very inaccessible, right? So for that, we can use a drone. And then, so here, for example, he has gone there, and so of course he has taken a lot of safety measures, his helmet and this rope and all. Then he is measuring what, or maybe taking the pictures, or what is happening there. So similarly, we can use a drone, so which we can control from the ground, and then we can take different flights of the drone, and then we can take photographs, maybe 300, 400, or thousands of photographs we can take. And then laser scanning is there, digital photogrammetry also we can use for the visual inspection process. So this is a simplest approach. So visual inspection is a simplest approach and it's the first approach which we use. But this requires a lot of experience. Not to take the data, but to interpret from the data, we need experience. And from this, we can identify if there are any irregularities. For example, here you can see there is spalling has occurred, this cover concrete has gone, some portion is exposed, and then maybe some corrosion is there. So we can identify what all are the irregularities which has happened. And if there is any discontinuity of the structure, if some portion is missing, or if it is out of plumb, that means it's not vertical. So if there are any cracks, damages, any column is settled, so all those things can be measured or can be seen, and we can make a detailed geometry of the structure. Geometry can be drawn and the material, and we can do the survey. Right, so this is an overview of the visual inspection process. Now we can measure strain, temperature, acceleration, wind speed, pressure. So depending upon our requirement, we can fix the sensors pertaining to what parameter we are intending to measure. Even acoustic emission. So to measure the forces, we can use this load cell, right, to measure the displacement, what is how much it has displaced. We can use this LVDTs or linearly variable displacement transducers to measure the change in the distance, and then accelerometers to measure the acceleration, then strain gauges to measure the strain in the structure. So these are the instruments which can be used to measure these data. Now we can also use laser test. For example, we can consider this structure. So for example, let us consider a beam, concrete beam, which is having a crack, right? So with this, if you are putting a laser source, this can emit some rays, right? And then this is reflected, and then we can measure, there will be a polarizer, and then there will be a shearing device, and then there is a camera, and then we can process this image. So whatever image, so here it's a light source, and then with this we are taking some photograph, and then we can process this image and find out if there what type of crack it is and all. Similarly, we can also perform some sonic test, wherein, so suppose we are considering the same beam with the same crack, you are placing two transducers, okay? So it can be one transducer and one receiver. So as in we use this ultrasonic pulse velocity test. So here we are, there is a transmitter. So these two transducers are there, of which one is a transmitter and one is a receiver. So from this transducer, there will be some waves which would be passing, that is ultrasonic wave would be passing. So then this will pass from this transmitter to the receiver. So if there is a crack in between, this wave will take a longer path. Cannot go directly like this. It will take a longer path because this wave cannot transmit through vacuum. So if there is a crack, there is a vacuum created. So this will take a shortest distance. So like that, if there is a delay in the time, we can understand that there is some anomaly or crack in the structure. So with this time, we can measure, and then there is a data logger. So from that, we can understand what is the condition of the structure. Similarly, we can use a technology known as infrared thermography, where in the same principle, there is an infrared radiometer, right? There is an energy source, and then we'll put this radiation through the structure, and then there is a thermal radiation which is reflected. So from this, we can measure what is the status, or if there is a crack or anomaly in the structure we can measure. So there are different methods. So for example, there is static based structural health monitoring, wherein damage will alter the static properties, for example displacement, rotation, slope, etc., which are not dependent on time, or for example it is static. So obviously the other would be the dynamic. So dynamic or vibration based structural health monitoring. So if the damage is of altering the dynamic properties of the structure, for example frequency or time period. So if frequency of time or time period is changed, the stiffness of the structure would be changed. So just to refresh, what is frequency? So if you have a wave like this, right? So one oscillation. So this is our wavelength, right? So you know what is the frequency? So 1 by T. So that is frequency is a number of oscillations per second. So if there is any damage or any alteration in the frequency or the time period, we can understand that the stiffness of the structure has changed. Then similarly, we can look into the mode shapes of the structure. So the mode shapes will give the idea of whether there is any change in the or any deformation has occurred in the structure. So mode shapes will give us an idea of the deformation of the structure. Similarly, another dynamic property is damping of a structure. So damping, so we'll define these terms. So but for just to mention the use, so by using damping, we can understand or detect any internal changes have occurred in the structure. So let us see what is mode shape. So what are mode shapes means? So if this is the structure, so a structure when subjected to dynamic load, it will vibrate, right? So when it vibrate, it is having different mode shapes. So that is how it is moving. For example, if you consider this structure, so if it is a tall structure, if you consider, if it is subjected to some dynamic loading, that is heavy wind load, or it can be an earthquake load, so it will move in different modes. So it is the first model shape would be like this, right? The second mode shape or the third mode shape. So like that we can define. So it will be having various translations, rotations or torsions. So depending upon the structure, if you do the dynamic analysis, we get these type of movement. So this is known as the mode shapes. So when a structure vibrates, it does not move randomly. It vibrates in a specific pattern. So these, one second. These patterns are known as the mode shape. So how this structure is vibrating. So that is known as the mode shape of the structure. So first it will vibrate like this. Then upon different loading, it may vibrate like this. Okay, so so these are known as a mode shape. So each mode shape correspond to a specific natural frequency. So what is the frequency of the structure without any loading, external loading, is known as the natural frequency. So the shape shows how different parts of the structure move relative to each other. For example, here some part are moving a lot, while these two parts, so at the top and bottom, it's not moving much. So this shows and some parts are remaining stationary. So these are known as the nodal points, and then some parts move relative to the initial reference point. So for example, here it is moving with respect to this. So this point has a more displacement. So mode shapes are independent of the external load. So this happens even if there is no external load. So this depends only on the structure's mass and stiffness. So there is no need of inputting the external load acting on the structure. So these mode shapes will help in identifying critical regions in a structure which are prone to damage during a vibration. So if there is a vibration, you are generating the mode shapes. So these mode shapes will help us in identifying which region has undergone more damage. So next is damping. So as we discussed, so when there is a disturbance in a structure, so or a vibration occurring, so this vibration will die out in a particular time. So that dying out is known as a damping. So the damping is a mechanism by which the energy the vibration energy is dissipated in a structure, typically in form of, it can be, so if there is an earthquake occurring, the structure will absorb that energy, and then that will be uh, generated, or it is dissipated through different forms. So it can be heat, it can be friction, it can be material deformation. That mechanism, so initially it would be higher, then it is slowly, if you see the graph, it is slowly dying out. So this process is known as damping. So when a structure, so like a bridge or a building, vibrates due to wind, traffic, or earthquakes, damping helps to reduce those vibration over time, so bringing back the structure to rest. So for this reason only, we introduce some dampers into the structure, so we can deliberately reduce the effect on the structure. So this prevents the excessive vibration on the structure and also helps to prevent the structures from failure or fatigue. Also, this damping, if you provide any damper, which will improve the comfort and safety of the structure. So now let us move on to the dynamic or vibration based structural health monitoring. So after collecting the data from the experiments, the analysis of the structural behavior and assessment of the global health. So for this, we can use this numerical modeling. That is, using some softwares or FEM model we can use. So we can use some software such as Abacus, ANSYS, etc. And we can model the structure and create a finite element model. We can perform this operational model analysis, and then we can identify the system. So system identification is nothing but identifying the frequency, mode shapes, etc. So use model analysis or finding shapes, and we can then from that we can prepare the numerical model. Then we can update in our baseline model. So validated numerical model is damage prediction and assessment of effective interventions. For example, what is the seismic vulnerability? So all these things we can, so once we create a numerical model and then we can input some earthquake data, so we can understand how the structure will behave in an earthquake. So we can, after that, we can put this preventive or corrective actions. So this is a chart showing the how the process is done. So a baseline model is generally a numerical model or a finite element model of the structure. So just built in using the initial design data and boundary condition. So here we will measure this model properties of the structure. Then we will feed into the baseline model. Then we'll compare. If there are any discrepancies is there, we will update the model. So this baseline model represents a theoretical or expected behavior of structure before and before any damage or alteration. So after that, we will compare and then update the model. Then another term is numerical model updating, wherein the process of adjusting or refining a numerical model. If we find out a numerical model or develop a numerical model to predict the dynamic behavior, such as what is the natural frequency, what are the mode shapes, how the damping is occurring. So which is matching with the measured data from the actual structure. Then, so these are the steps. So we'll measure the model properties from the experiments. So we will place some accelerometers or in the structure to get the mode shape. So from that, we will get the mode shapes and frequency. So this process will be clear when I explain the case study. So with the how we have done, so with that I will explain. But before that, I'm just giving an introduction of these terms so that it will be easy for you to understand. So we'll measure the model properties from the experiments using the accelerometers, and then we will find out the mode shapes and frequencies. Then we'll compare these with the model properties predicted using the baseline finite element model. Then we'll identify if there are any changes or are there. Then we'll update the model parameters. So these are the steps involved in the structural health monitoring process. So, why we have chosen slender masonry structure is that, so slender masonry structure means it is having one dimension is larger compared to the other dimensions. For example, a bell tower. Okay, this bell tower or watchtower. So here we can see this, it is having a height. Height is higher than the other parameter, other dimension of the structure. We can see in this figure long columns or chimneys, right, and minarets. So these are the slender masonry structures. So it is, so the wind effect and all will be, or the vibration will be more for this, these slender masonry structures. So now why in the research or in the study we have used masonry minarets? It is because if you consider the, for example, here in this figure you can see, so this is actually a mosque, and then in the adjacent you can see a minaret. Okay, then this is a figure after the earthquake. So these are the minarets in Turkey. So after the earthquake in 2023, we can see that here this structure is remaining as it is, but whereas this next structure is not there, so it has been severely damaged during the earthquake. Similarly, here also we can see this is tall slender structure. So after this earthquake, the structure has been demolished or really damaged. So this minaret structure is deeply affected. So that is why for this study, we have used this masonry or masonry minarets. So it is an integral part of the architectural heritage, and it has suffered significant damage disasters, particularly from when it is vulnerable to earthquakes. So, assessing the current condition and the integrity of a minaret, it is actually very important because it is a historic structures. So, there is a proper need for structural assessment or to address the actual behavior of these minarets for conservation and preservation. So for this purpose, so mostly minarets are used in Islamic culture to call for prayer and as mosque symbol. And then there are slender structures. I don't know why these drawings are coming on the screen. Any participants are doing this? Okay. Am I audible to you?
Yes,
Are
yes,
you
ma'am.
there?
Yes, yes,
Yeah.
yes, yes.
Yes, ma'am.
Okay. Okay. I'm seeing some drawings
Yes,
on my
ma'am.
screen. I don't know how it is coming. All right. Let's continue. These minarets are like, it is a cantilever like structure, and it is sensitive to horizontal and dynamic load such as earthquakes and some wind or traffic. So this is a picture showing the structure of the minaret. So it is having a footing, right? And then there is a transition segment. So this is a classical minaret structure. Then there is a cylindrical body, then followed by a balcony, and there is an upper part, and then top there is a spire or cap, and then at the top we can see an end ornament. Okay, so this is a classical minaret structure. So this is a cross section at the balcony level. So we can see the core, which is starting from the bottom to the top, and then we can see some stairs also. We can watch we can move up and we can watch from here. So in India, so this project was funded by CDRI, and then so with the help of Archaeological Survey of India, we could take some readings from the actual structures. So so these were nationally protected monuments. So Archaeological Survey of India has 3696 nationally protected monuments and 42 World Heritage monuments or sites. So from this, various structures were taken. So one is Julta Minar in Ahmedabad, Gujarat. Then we have also taken Chand Minar from Aurangabad. Then Hiran Minar from Uttar Pradesh. So these structures were selected, and then the dynamic study or some readings were taken, and then we have predicted the damage assessment of these structures. So here is a workflow of this process. So first was a field documentation. So for this, we went to the site and took the geometrical data using drone survey and non-destructive testing method. And then after that, we prepared a baseline model using the finite element method or finite element software. And then after that, the model updation. So the model properties, for example, the mode, shapes, frequency and all were calculated using empirical relations. And then system identification results. So system identification is nothing but frequency and mode shapes. So they were used for the calibration of finite element model of the structure. And then dynamic analysis was carried out. Okay, and then after the dynamic analysis, what are the horizontal drifts which have occurred, what are stresses occurred in this minaret were done. So this was a drone-based survey. So this DJI Air 2S drone was used. So this is how the flight was set for the drone. Okay, so let us consider this building. So here this minaret. So this is a drone. So using this drone, there were number of photographs taken. So over 300 to 400 photographs were taken for each structure. So like that, we took the geometry. So like that only we could understand what is the geometry of the structure. So first let us consider the Chand Minar in Maharashtra. So this is a typical structure. So wherein we have a footing, right? There is a like this is a bottom structure. Then we have a balcony here at this level. So from this we can enter into this minaret, and then we can climb in using the steps and come to the balcony. And then here there is a end ornament. So this is overview of the structure. So this Chant Minar consists of arch plinth and made up of, it was the material used is basalt, and the exterior is coated with some plaster of red sandstone, and the internal spaces such as areas within the arches are coated with white plaster. So here we can see the white plaster in this structure. Okay, it has 24 chambers and a mosque is there at the base. So these are the details of the structure. So if you go, so this field documentation was and the geometric survey was done using the drone. So this is at the ground level. Okay, then at the mosque, this is at the mosque level. And then at the top, we have this minaret. So at different levels, we have taken the readings. And then next structure is Hiran Minar in Uttar Pradesh. So here there is a square platform, then an octagonal plinth. Right, so this is a pictorial representation of the structure. So this Hiran Minar, we can see a number. Actually, this is representing the. This represents how the maybe during this Mughal period and all, after the any war is there. So this elephant tusk was taken and put on this minaret. So that is a story behind. But it's just not original, made of some plaster material. So this is a Hiran Minar photo. So next is a Julta Minar in Gujarat. So here we can see this Julta Minar. So as the name suggests, so there are two minarets. So here two are there, and then if one is moving, the other one also will move. So that is a name. It is so Julta means moving, right? So that is how the name Julta Minar came. So, so some part of the structure was taken for some study, but then it was not kept back by the British Empire. So, during the British Raj period, it was taken to detect how this minaret, why it is both are moving. So, such studies were conducted. So, these minarets are the best example of the shaking minarets. So here the other parts of this minarets did not survive. So only this part is there existing right now. So here also we went and took the reading. So here, so this is my scholar who went there to take the reading. And then you can see the minarets here, and this is a connecting structure. And already there are some damages occurred, and then some preventive measures have been taken. So with because of that, you can see some horizontal steel belt which were taken to protect this structure. So this is the geometry of this minaret. So this is at the bridge plinth level, you can see. Then at the minaret level and the bridge level. So here we can have the access to this part. So we can, so there is a stair like this. And with the help of the stair, we can go to this region. Okay, so this is while taking the field documentation and non-destructive testing. Yes.
Now continue, please, ma'am.
Okay. So the material properties and characteristics of the minarets were taken using the non-destructive testing method. Because it is a historic structures, we cannot do some laboratory testing or destructive kind of testing or core, nothing is possible. So we have to only do the non-destructive testing. So for that we have used this ultrasonic pulse velocity test. So using this, we could get the velocity and modulus of velocity of the structure. So this is how the ultrasonic pulse velocity was, the equipment was used to measure the details, and velocity and modulus of velocity was found out using this UPV. Then after that, ambient vibration testing was carried out, which is also a non-destructive testing method. So which is to identify the dynamic property. So from UPV, we could get the material property. And then using this ambient vibration testing, we could get the dynamic property of the structure, such as the natural frequency, mode shape, damping ratio. So this is the, so for this ambient vibration testing, we use this accelerometers. So these are the photograph of the accelerometers which we are used. So we have placed the accelerometers at different location, and under the natural load or without any external load, how the structure is vibrating. So with that we could measure the so these sensors or accelerometers are installed on different parts of the structure, and the vibrations were recorded for a period. And then after processing data, we can get the data, and then from that operational model analysis were done. So with which we are taking this natural excitation and what is the frequency response. And then from that we will identify what are the modes. So this peak of these vibration or this frequency will give the mode shapes and modes, and then from that we can find out the mode shapes as we discussed. So what are the mode shapes and all we know. So from these data, processing the data, we could find out the mode shapes of the structure. And this operational model analysis technique was used to determine the dynamic characteristics of structure without applying artificial or any external forces. So at different locations, these accelerations were different. And then from this difference, we could plot the mode shape. So from this we can get, so from this we can get the mode shape of the structure. So after getting this finite element model, so once this model is got, we can, so with this frequency, mode shapes and all, we can model a finite element model of the structure. So for that, we use the Artemis software. And then after this, we can put in some earthquake data of the previous earthquakes or which has occurred. And then the seismic analysis, we can get the strain, stresses, damages, and deformation. So in that sense, we can understand that if there is a earthquake occurring, what or how the structure will get affected. So the same thing can be done using AI techniques. So for which we can do some AI assisted inspection process. For example, in the beginning, we during use, we can also develop some apps wherein we can photographs and then feed into that. So if you train the data, we can identify what are the types of cracks or any damages which has occurred. So either from the drone or even using the mobile phones or using the webcam, we can collect the data. Then some data cleaning is done. Then data labeling. For example, if it is like this, we can identify it as falling. If it is data is like this, we can label it as a crack. Or if there are any blistering or any cover is getting out, we can label it like this. And then we can use this deep learning tools. Then testing, some data will be kept for testing. And then we can use as a damage detection and then damage classification. Then we can find out if whether it is a crack, whether it's falling, whether it's efflorescence, if there are any missing components. So all these can be assisted using artificial intelligence. So coming to the summary and conclusions. So we discussed about structural health monitoring, so which helps in early detection and diagnosis of potential damages in structure and preventing some catastrophic failures and reducing the maintenance cost. So by structural health monitoring, we can predict when the failure is going to occur, and then we can also reduce the maintenance cost. So advancements in technologies such as sensor technologies, data analytics, machine learning. So using all these techniques, we can improve the effectiveness and efficiency. And these technologies enable us to continuous and real-time monitoring and also provide insights to the structural integrity of various structures. And also structural health monitoring and technology development will pave way to more resilient and intelligent infrastructure system. So we also discussed about the case studies wherein we took data from various heritage minarets and then processed using this structural health monitoring, and then while using the ambient vibration testing, we could model the FEM model of the structure, and then with that we could perform the structural analysis, seismic analysis, and we could predict what are the strain stresses which are occurring in the structure. So I would like to acknowledge the Coalition for Disaster Resilient Infrastructure, which funded this project, and also the Archaeological Survey of India and the softwares which are available in National Institute of Technology, Puducherry, for completion of this work. So these are the references. So now it's open for discussion. If you have any questions, please feel free to ask. Thank you.
Thank you, ma'am. If you have any query, please feel free to ask directly or use the chat box.
Hello, am I audible?
Yeah.
Yes.
Ma'am, the case study that you showed, that is for the natural, the structures were under the natural load only. There was no external impact on that,
Yes,
right, ma'am?
yes.
But in real life situation where we are facing challenges, for example, the bridges collapsing suddenly, or recently there was a school where the wall collapsed. So if you have to apply the same case study where there are dynamic forces applicable, a lot of vehicles are running. So in that case, what are the additional factors that we'll have to consider?
Yeah, actually, the idea is to make the baseline model, and then after that we can apply the seismic load. For example, I have shown in the slide, like after I'll just share it once again. Yeah. So the idea is we have got this first structure. Okay, so with this parameters, we are applying. We got this finite element model, and this in this finite element model, what are the actual forces occurring? So, for example, if there is a seismic force, that force we will apply in this model, and then we will do the analysis in the software. Then we can find out where the stress, strain, and all have occurred. Is it clear?
Yes, ma'am. So any additional force, like in this case, you have considered seismic forces. So any additional forces that is coming, whether that is a
Yes,
UDL or a
that is
point
what.
load, that
So
will
after
factor.
creating this, yeah. So here I have considered mainly the seismic force. So
Right.
whatever is actually actual force, whatever we need to input, after we get this model, we can input in that model depending upon the actual load which we can get.
Okay.
One more question in chat box, ma'am.
Okay.
How do you deal with sensor calibration and environmental noise? Question asked by Anita Annie.
Yeah. So regarding the sensor calibration, so if you get the sensor itself, there will be some instructions. So using the basic things, we can do the calibration of the sensors. And then environmental noises, some data maybe after getting the data, some noises may be there. So we may have to take the best data which are available. So some data we may have to discard. So that is the only option.
Have any more? So please ask. I think
Hello,
you.
ma'am.
Sure, please.
Uh, Ma'am, is
Yes.
this like a baseline model that you have shown is applicable for the other structures also?
No, no. It is for the structure alone.
It is for a particular structure, right?
Yes, yes, yes.
Okay.
I think we cannot generalize this because for each structure the parameters would be different. Like for example, the Young's modulus. So that is why we have went there and taken the Young's modulus. All this material property we have taken, the elastic constant that we have inputted. So I don't. It cannot be applicable to all the structures. So basically for the heritage minaret, so the structure also, shape also may vary. So geometric properties will be different. So we have to go there and take the readings, and then we can only predict the. So this is applicable for this particular structure. It cannot be generalized.
I have one more question, ma'am. Like,
Sure.
uh, as this is a heritage structure, so but if we talk about like normal structures, we don't require any permissions. But if it is a heritage structure, we require a lot of permissions from the
Yes,
archaeological departments. Right. So
definitely.
what are those like permissions or what conditions we have to consider before starting any monitoring of any heritage structures?
Yeah, that is actually we have to approach this authorities from Archaeological Survey of India. then with their permission or some of their officials also may be present, and with that also, for example, we had plans to extend this to Qutub Minar also, but we could not get access to there. So maybe some structures, even the Archaeological Survey of India is not giving permission. So it depends upon our luck also. Like if you go there, if they are permitting, and also if there are any threats or something like that, they won't permit us. So that things we cannot determine initially, but we can propose a structure if they are and approach the authority. If they are permitting only, we can do this. And since it was funded by this CDRI, that was also an added advantage. So with that, if you go means they will, it is easier to get permission.
Okay, right.
Thank you. Thank you, Nidhi ma'am, for your
Thank you so much.
insightful and engaging session on structural health monitoring. Your analogy of structural health monitoring as a doctor-patient relationship provided a clear understanding of the need for continuous structural assessment. The discussion on damage mechanism, the importance of baseline model, and the application of structural health monitoring in preserving slender masonry heritage structure was truly enlightening. Your case-based uh, insights on iconic masonry minarets such as Chand Minar, Julta Minar, and Hiran Minar added immense value. We sincerely appreciate your valuable contribution to our FDP and look forward to future academic
Thank you so
engagement with
much.
you, ma'am. Thank you,
Yeah.
ma'am.
Thank you for inviting me once again. Thank you so much.
Thank you. We also extend our heartfelt thank you to all the participants for joining us on second day of faculty development program. Your active engagement and enthusiasm contributing significantly to the success of today's session. We look forward to your continued participation in the upcoming days of the faculty development program. Thank you, all the participants. Today's session are completed. Thank you.